All right, we are going to go over this second set of notes. It's kind of the same thing, a little bit different, and since we don't have graphing calculators, we're going to take a different approach, okay? So I had you look at the z-score table, okay? Make sure you have that handy. We're going to be using that from now on. With these notes, okay, you are going to need to know this formula. So it comes out a little bit weird on mine, okay? So this should be z is equal to x minus x bar over standard deviation, okay? This is the formula we are going to use from now on, okay? Now, when we look at this problem, part A, so we have our little condition up here. We're talking about heights of oak trees. So with oak trees, it says normally distributed with a mean of 90 feet and a standard deviation of 3.5. About what percent of the white oak trees heights between 86.5 and 93.5? Okay, now I'm not going to answer this question because we're going to go through, we have different questions on here already. Okay, so I just want the mean of the standard deviation for right now because I have different questions to answer. All right, so what I'm going to do first is I'm going to set up my normal curve. Okay, so it says my mean is 90, and then you can draw your 3 lines to the right, 3 lines to the left. Okay, so our standard deviation is 3.5. So we're going to take 90 and we're going to add 3.5 every time we go to the right. So the first line is 93.5, add 3.5 again, you get 97, add 3.5 one more time, and you get 100.5, sorry. Okay, so 3 lines to the right are those 3 numbers, and then we're going to subtract on the left. So 90 minus 3.5 is 86.5 for the first one. Minus 3.5, so we're going to have 83. And then minus 3.5 again, we're going to have 79.5. So 3 lines to the left, 3 lines to the right. Now, I want to know, it says find the probability that a randomly selected white oak tree at most 40 feet. Now, 94 feet. I do not have 94 on my table, okay? I know that it's somewhere between 93.5 and 97, but I cannot just guess, okay? We're going to have to use that z-table now. So before the last set of notes, I asked whatever my question was that I asked you, it had the number on the chart. So all you had to do was add up the probability or add up the percentages. This time, 94 does not fall on my curve. So I'm going to have to use my z-score formula, okay? Basically what this does is it turns my information into a standard curve where the mean is 0 and my standard deviation is 1. So 1, 2, 3, -1, -2, -3, okay? So this z-score formula turns my information into means of zeros and standard deviation of 1s, okay? This will help us. So now we're going to use the chart, okay? So we're going to use the chart, but before we use the chart, we need to plug our information into the formula at the top, okay? So we are going to take, so z is equal to, now the x represents what you're looking for in your question. The mean is what's given to you, and the standard deviation is what is given to you, okay? So you're looking for 94. You are going to subtract your mean, which was 90, and you're going to divide by your standard deviation of 3.5. So you're going to take 4 and divide it by 3.5, okay? So 4 divided by 3.5 is 1.14. Okay, so 1.14, so let's say z equals 1.14. Now that's not my answer yet, okay? But that 1.14 on this chart right here on my line is about right here. Now, that looks the same as what I drew here, okay? It's a little bit over 1. This one's a little bit over 1 standard deviation too, okay? So all it does is it converts my data into 0, 1, 2, 3, negative 1, negative 2, negative 3, okay? Now I'm going to use my chart, and I'm going to find the probability, okay? So you're going to go to your table. So I'm going to go to my table, okay? Now, it looks confusing because there's a whole crap ton of numbers, okay? What we were looking for was x is equal to 1.14. So the first thing you're going to do is you're going to look over here on the left-hand side, and you're going to find your 1.1 because it only has 1 decimal here, okay? So on the left-hand side, it has your 0.1 decimal, and then the other one is 1.1 decimal, okay? So what you're going to do, oops, okay, you're going to look for 1.1 on the left, and then you're going to look at the 0.04 column, okay? So let me actually open this up so I can write on it. So we're going to go to my Z table. Okay, so what we were looking for, my Z was 1.14. That's what we got when we divided, right? So the first thing you're going to do is you're going to look on this left-hand side, and you're going to find your whole number and the first decimal, okay? So what I'm looking at right here is I'm looking at 1.1. So 1.1 is right here. Now I want to look for 0.04, okay? So this number right here is 0.04 on the top, okay? And then you're going to find the 0.04 column, and you're going to highlight it. Now, the number that you see when you highlight both of those is this number right here, 0.879, 0.879. That is your answer to your problem, okay? So your probability is about 0.88 or 0.879 or something like that. I would mostly likely just for you to round it to the nearest 2 decimal places. So round it to the hundredths, so I would say 0.88. Okay, so you're going to go back to your problem. And you're going to say that your answer here, let's do it in blue. Okay, your answer to this whole problem is 0.88. Okay, so this is the score that we found from your score minus your mean divided by standard deviation. Okay, now that was used on your chart to find the probability. Okay, let's do the second one. About what percent of white oaks have heights less than 98 feet? Now, we can go back and we can still refer back to this one because it's the same problem, okay? We have our mean, we have our standard deviation. We don't have to draw a new picture. We can just look at this one. Now, it says less than 98 feet, okay? 98 is not on my curve. 98 is a little bit more than the second standard deviation. Okay, but again, it doesn't fall perfectly on a standard deviation, so I cannot just add up probabilities, okay? I'm going to have to use the z-score, so my z is going to be equal to what I'm looking for, which is 98, minus my mean divided by standard deviation. So I have 8 divided by 3.5, and 8 divided by 3.5 is 2.285. Okay, now since your z-table counts to 2 decimal places, you could look on your z-table at 2.29. So this is your z-score. Okay, we're going to use that to find the probability. So we're going to go back to our z-table. Okay, I'm going to erase all this so that way we can highlight everything again. Okay, so remember, always look at the left first, and then you're going to look at the top. Okay, so on the left, you're going to look at 2.2. Let me erase this. Okay, so now your z-score is 2.29. Okay, now you are going to look at the left-hand side first. Okay, and you're going to find your 2.2. So 2.2 is here. All right, and then you're going to look on the top for your second decimal place. Okay, your second decimal place is 0.09. Okay, because we already found these two. Now we just need this number, which is 0.09. Okay, so you're going to look on the last column. Oops. Okay, so the overlapping number between the blue and the yellow for our 2.29 is 0.989. So that is your probability. So you'll go back to your problem. And your answer is, oops, not your Z. So your answer is I'm messing this all up. 0.989. Remember, your probability has to be between 0 and 1, okay? So again, when I drew my blue line up here on my chart, it was closer to 2 standard deviations and it was less than that. So I should have everything from this blue line shaded. Now that is majority of my standard table, so therefore my probability should be a lot, okay, or close to 1 as possible. All right, now let's do the one on the bottom. What percentage have heights between 84 and 92? This one's going to be a little bit different because it is the word between. You're going to have to find 2 z-scores, okay? Because z-scores, let's go back to the chart. If you look at the top, your z-scores represent everything to the left. So if you look at what I shaded here, whatever your z-score is, whatever your z-score is, you shade to the left, okay? Now, if you look at the second page, first page, the z is on the right because your mean is technically in the middle, okay? So your mean is technically here, okay? So your z-score is to the right and it's shaded. That is for this top part. The second page, just got copied over a little bit different, but it's okay. Okay, the second page, your mean is here. Okay, but your z-score is to the left and it's shaded. Okay, so if you have a z-score that's to the left, you're going to use this table. If you have a z-score, to the right of your mean, you're going to use this table. Okay? All right, so we need 2 z-scores here because we're looking at between. So if we were to look at, let's make just a sample one here. My mean is 90. I'm looking for a probability between 84 and 92. So 84, let's draw my 2, 1, 2, 3, 1, 2, 3. I'm looking for a z-score between 84 and 92. So 84, if you refer back up to here, 84 is a little bit more than the second deviation, which is 83. the other one I'm looking for is 92. So 92 is a little bit over here. And you're looking for everything in between. Okay? So if I were, okay, I need to get 2 standard deviation, or I need to get 2 z-scores. Okay? So I need to use this one right here, because this right here shows me everything to the left. And this one that I find will show me everything to the left. So I'm going to have to do some subtracting here, okay? So I'm going to take my first z-score, which is 84, and I'm going to find it, okay? So 84 minus 90 divided by 3.5. Let's see, that gives you 84 minus 90 divided by 3.5 is negative 1.71. That's okay if it's negative, just leave it alone. Okay, and then I'm going to find my 92. So 92 minus 90 over 3.5. So 2 divided by 3.5 is 0.57. Now, this is okay that we have a negative and then a positive, because remember what I said, if you have a z-score to the left of the mean, it's going to be negative. If you have a z-score to the right of the mean, it's going to be positive. All right, now we need to go to our chart and find a z-score for negative 1.71. Okay, so let's erase this. Okay, so since it's negative, you do not see any negative numbers on here. Okay, the first z-score that we're finding, remember, was to the left of the mean. Okay, it's to the left of the middle. Okay, so it's gonna look like this one. Okay, it's gonna look like this. So we need to use this other side. Okay, if you notice on the left-hand side, these are all negative. Okay, so if you have a negative number, just look at where the negative chart is. All right, so you have all your negative numbers here, and then you have your second decimal up here. So you're still doing the same process, okay? So the one we were looking for was negative 1.17. So we are going to go to negative 1.1, which is here. And then we're going to go to 0.07, which is everything here. Okay, my overlapping is 0.1210. Okay, so let's make a note of that. So 0.1210. Okay, so 1.1, oops, not that. It was 0.1210. So that's my probability for this z-score. So that is this z-score to the left, that is that probability. Okay, now I'm going to do the other one. Okay, so 0.57. So now we're going to go on the z-score and look at 0.57. Now I'm not going to use this chart because it's not negative. So I'm going to go back to the first one and I'm going to find 0.57. Okay, I am going to go to 0.5, which is here. And I'm going to go to 0.07, which is here. Okay, so my probability is 0.7157. Okay, let's go back to our paper. So 0.7157. Now, you're not going to have two answers for this problem, okay? Because that z-score right here gave you this and to the left. Now, there is some overlapping here. You need to get rid of the overlap because you just want, remember, you want between 84 and 92. So you want this middle red bit, okay? So you're going to take your larger number, which is this one, and you're going to subtract your smaller one because I don't want this to the left. I want this one here and then subtracting the leftovers because I just want the middle, okay? So you're going to take 7157 and subtract 0.1210. So your final probability and your final answer for this one is 0.59 is your probability.